All right, welcome to day 2 of section 4.3. We've covered 4.3.1. I know 4.1 and 4.2, where did they go? They'll come back at some point in time. But we're on section 4.3 of day 2. So today we're going to work on multiplying and dividing rational expressions. So we're going to start out with a little bit of a review. So we've got x cubed minus 5x squared minus 24x, and that's going to be over x cubed plus x squared minus 72x. Okay, so we're going to go ahead and factor them as much as we can. So I'm going to kind of start up here at the top. We're going to factor out an x. So that gives me x squared minus 5x minus 24. If I use the x method, negative 24 and negative 5, that's got to be negative 8 and 3. So that's x minus 8, x minus plus 3. On the bottom one, I'll just change colors. I'll go the other direction. Factor out an x. It gives me x squared plus x minus 72. So that's going to be negative 72 and 1, so 9 and negative 8. X plus 9 and x minus 8. So we simplify that a little bit further. I probably shouldn't have written it way over there, but I did, so nothing I can do about that, I guess. So we simplify it. X divided by x, that's 1. I've got an x minus 8 in the numerator and in the denominator, so that's 1. So I got x plus 3 over x plus 9. Okay, so there's a simplified form. Remember the excluded values. We take the excluded values from the original. Oops, I didn't mean to erase. I meant to highlight. Let's try this again. From our original denominator. So when we look at the excluded values here, x cannot be 0, negative 9, or 8. So there's my solutions for the first one. That's just a little bit of review from Friday. Today what we're going to do is we're going to multiply and divide rational expressions. So we're going to start with multiplying. Multiplying fractions, as my 7th grade math teacher told me and said a long time ago now. It's almost 40 years. Wow. Anyway, so what my teacher told me, that if I have something like 3/4 times 2/5, that multiplying fractions is no problem. Take the top times the top and the bottom times the bottom, and then reduce afterwards. Okay, and 2 goes into both of those, so we get 3/10 is our solution. So if that's the way that you multiply fractions, when you multiply rational expressions, which are just a form of a fraction, we're going to take the top times the top and the bottom times the bottom. Now, my suggestion in this first example, we have monomials. When you have monomials, do exactly that. Take the top times the top and the bottom times the bottom, then reduce afterwards. If you start crossing things out, I mean, I could have gone over here in the 2, and I could have crossed the 2 out in the 4 and made that a 2 and done the reducing there. Sometimes that gets a little bit confusing, so my suggestion is just do the top times the top and the bottom times the bottom. 2 times 3 is 6. X times x squared is x cubed. Y times nothing is y. We've got 4. Y, and just writing it in alphabetical order. Z times z is z squared. So number-wise, 2 goes into both of my numbers. 2 goes into 6 3 times, and into 4 twice. I have x cubed in the numerator. I don't have any in the denominator, so we're just going to have x cubed in the numerator. I've got a y in both the numerator and the denominator, so that's 1. I've got a z squared in the denominator. Just bring z squared. There it is. There's your solution. And obviously z couldn't be 0 and y couldn't be 0, but whatever. Okay? So when you're doing monomials, my suggestion to just take the top times the top, bottom times the bottom, and then reduce afterwards. If you get a whole mess like this now, where you've got monomials such as 5x, and you have binomials or trinomials, binomials x squared plus 1, and a trinomial here, you want to factor anything and everything that can be factored first. Okay, so we're going to factor first. So 5x can't be factored. I'm going to leave that alone. That can't be factored. X plus 3 can't be factored. It's already in factored form. If I have x squared plus x, I can take an x out of there, and that leaves me with x plus 1. Okay, I'm just going to kind of doodle through that a little bit. X squared plus 2x plus 1. I think that's x plus 1 times x plus 1. If you needed to do the 1 and the 2, the 1 and the 1, then that's what you have to do. So I've got that factored. Now I go over to the third one. Over here, do the same thing, factor it, and that's going to give me x times x plus 1. GCF for this binomial is 5, and that gives me x minus 2. And I'm going to kind of scribble this out. Now you look for commonalities in the numerator and the denominator. So commonalities, I'm just going to highlight kind of, and they're going to kind of cancel each other out or become 1. So I've got an x plus 1 and an x plus 1. I've got an x plus 1 and an x plus 1. So those take care of each other. I've got a 5 sitting there and a 5 sitting there, so those are going to give us 1. So I think that's what we have. So on the top, we're left with, I'll highlight them in yellow, what we're left with. We've got an x there, an x there, and an x there. So x times x times x is x cubed. Over, we've got in the denominator, we've got x plus 3 and x minus 2. So we've got x plus 3 and x minus 2. And we're just going to leave it there. You don't need to do anything else with that. That becomes your solution in simplified form. Nothing else can be touched. I'm sorry, I'm just looking at the assignment today, just trying to see what your assignment does here, see if it makes you put in the excluded values today. Okay. 2, 1. So you don't even need to worry about the excluded values with these today. But if you were looking at the excluded values, you're going to look for the excluded values from your original statements. So -3, -1, and 2 would be your excluded values. Okay, so if we look at this next one, we've got x squared minus 16, which can be factored. And I'm going to factor it. So it's x minus, difference of squares, so x minus 4, x plus 4. Now this next one, it's 9 minus x, and what we want to do with this one is we want our x to come first. So what I'm going to do here is I'm going to rewrite this as negative x plus 9, but I also don't want my x to be negative, so this actually factors into negative x minus 9. And we always want to do this. We always want our x value to be positive, if at all possible, which in most cases it is. Okay, so kind of the opposites, because I know what we're going to see over here in just a second. But we always want to have our x value that's positive. So rewrite it, factor out negative, so I'm going to cross those out. This factors to x plus 10 and x minus 9. And then this is x plus 4 and x plus 10. And if you need to do the x method to do these, we've done these enough. You should be fine with that. So now I just looked to cross stuff out. I've got an x plus 4 and an x plus 4. I've got that x minus 9 and I've got that x minus 9. That's why we want to kind of do the opposite of it. I still have that negative sitting down there. That's still sitting there, along with that and that so far. Well, I think actually that's going to cross out and that's going to cross out. So I'm just left with x minus 4 in the numerator and a negative in the denominator, which we don't really like to do. So then all we have to do is switch the sign. So this is negative x plus 4. And you're done. But that's whole key. So again, if I have something like 8 minus x, I want to factor that into the negative of x minus 8. We're always going to do that type of thing when we're doing these. Okay? So multiplying, top times the top, bottom times the bottom. Division, not much different. But remember when you divide fractions, if I take something like 1/2 and I divide it by 3/4, you leave the first term alone, you change the division to multiplication, and you do the reciprocal. So this is be the same thing as 1/2 times 4/3. So 4/6, which is 2/3. So caution, big time caution here. Rewrite it first. Don't try to factor first. Rewrite it first, and then worry about your factoring. So this is going to be times x squared plus 3x minus 4 over x squared plus 5x plus 4. Now, some of you are looking at it probably as I do that, and well, why can't I just cross out the x squareds? Why can't I just cross out? You can't do that because remember, this is a thing. Those have to stay together. Okay, so now we have to factor. I'm going to factor that top one. There's 4 terms. If it has 4 terms, I'm going to try to do the box method. Box method doesn't work, then we got to go back to the other stuff. With any luck, the box method is going to work. That's x squared, that's 1, that's x. Oh. Oh, no, it doesn't factor.
Hello, I see a lot of teachers on here for Kimberly, so we will go ahead and get started. Kimberly was a referral from IST. Concerns with attendance, and I know she was a bar student last year, and we worked a lot with her on attendance last year. So I will open up to any teacher that would like to start for Kimberly.
I don't mind starting. I have
Okay.
Kimberly, and she's a great kid.
So dividing rational expressions. Nice thing about dividing rational expressions is now that we've taken care of the multiplication part already, dividing really isn't that bad. So when we're dividing rational expressions, you think about what happens if they're not rational expressions, what do we do? So if we had something like 2/3 divided by, 4/5. Remember, when you don't divide by fractions, you multiply by the reciprocal. So we leave the first term alone, change it to multiplication, and then the reciprocal is making the numerator the denominator and the denominator the numerator. Now my suggestion is when you're doing these, rewrite it first and then do your factoring of it. It just saves issues that happen if you factor first. If you can factor first, go ahead and do it, but you can't cancel anything, and that's got to be, you can't cancel across things. I mean, if they're on, they're in the same rational expression, sure, you can do that, but don't do it. Just rewrite it first like I did right here. It just will save yourselves a bit of a headache. Now we're just in the multiplication thing of the world, so we just got to kind of start factoring these. Box method is not going to work for that first one, so I'm going to go ahead and take out a negative. Let's see if negative 1 is one of the zeros. We've got 1, 3, 3, and 1. 1, negative 1, 2, negative 2, 1, negative 1, 0. Perfect. So that's x plus 1 is a factor. And then this is x squared plus 2x plus 1. And that factors. So this is x plus 1, x plus 1, x plus 1. Okay, so that's my new numerator, and I'm just going to kind of write that over here. Where to put it? I'll just do this. Nah, we don't want to do that. So our new numerator is x plus 1 times x plus 1 times x plus 1. X squared minus 1, that's x plus 1, x minus 1, times x squared plus 3x minus 4, that's x plus 4, x minus 1. And then the last one is x plus 4, x plus 1. So now we've got that all figured out. So we've got an x plus 1 and an x plus 1. We've got an eraser, which I don't want. We've got an x plus 4 and an x plus 4. I've got an x minus 1 and an x minus 1. I've got an x plus 1 and an x plus 1. So I think all I'm left with is x plus 1. Good. There's your solution. Okay. Let's look at this second one. So we've got 1 over x squared plus 9. I'm just going to rewrite it. Times 3x squared minus 18x over x minus 6. So the first one can be factored to 1 over, if I take an x out, that's x plus 9. If I take a 3x out, that leaves me with x minus 6. Over x minus 6. Looks right to me. So those cancel out. I've got 3x on the top and x on the bottom, so my x's are going to cancel each other out, leaving me with 3 over x plus 9. There's our solution. And the last one, I think we're probably in good shape, but let's do one more. So x plus 2 over x to the 4th minus 16 times x cubed plus 4x squared minus 12x. And yes, I'm having just as hard a time as you probably are not factoring them right away. But just, it causes far less mistakes. So x to the 4th minus 16, that's x squared minus 4 times x squared plus 4. So x squared minus 4, that becomes x minus 2, x plus 2, but then we still have x squared plus 4, times, I can take an x out of there, and that leaves me with x squared plus 4x plus 12, minus 12, sorry. Minus 12, and so that's x plus 6 and x minus 2. So x plus 6, x times x plus 6 times x minus 2 over 1. So x plus 2 and x plus 2, x minus 2, x minus 2. So that leaves me with x times x plus 6 over x squared plus 4. Right on time. Actually, second hour algebra or fifth hour algebra 2, you were just honors algebra 2, you're about to enter the classroom. So have a great Christmas break, everybody.